Hi, welcome back. So let's discuss about the hypothesis testing for a population mean. Now remember class, we are still talking about the traditional approach of conducting hypothesis testing, and in this video we're gonna go specifically, okay, to discuss about the hypothesis testing that you can do for hypothesis, okay, for a claim involving one population mean, okay, specifically for one population mean. So this is how to conduct the hypothesis testing using traditional approach method. Okay, so yeah, first let us look at the three types of hypothesis testing. Okay, so if it is involving one mu, the two-tailed test will look like this. Okay, mu equals to a certain value that will be given in the question. Okay, mu not equals to the hypothesized mean. Okay, if it is a right tail test, then your h now will be mu is less than or equal to the hypothesized mean, and h1 will be mu greater than the hypothesized mean. Or if it is a left tail test hypothesis testing, the null hypothesis will consist of mu greater than or equal to the hypothesized mean, and the h1 will be mu smaller than the hypothesized mean. So yeah, again class, the hypothesized mean here, which is mu naught, will be given in the question. So you really need to read the question carefully and identify what is the hypothesized value given. Okay, and this hypothesized value can take any real value from negative infinity up to infinity, okay, as long as it makes sense for your variable lah. Kan, for example, if your variable is about CGPA, okay, so it should be from 0 to 4 only. Okay, but don't worry, this value will be given to you in the question. Now, these are the three formulas, okay, to calculate the test statistics value. So please recall the 5 steps of doing traditional approach hypothesis testing. In the second step, you need to calculate the test statistics value. So if your hypothesis is about one population mean, you need to choose one of these three formulas. Okay, so if the question given to you is the case of sigma square is known, so your test statistics should be z-test in the formula of x bar minus hypothesized mean divided by population standard deviation divides square root sample size. Okay, so this is the z-test formula if it is the case of sigma square is known. But if the question given to you is the case of sigma square is unknown, sample size greater than 30, it is also a z-test. Okay, it is also a z-test, but instead of using sigma, because the sigma is unknown, so you cannot use sigma, right? So you should use s. Okay, so your z-test here, use s in the formula. Okay, so the test statistics for this case is a z-test. But if the question given to you is the case of sigma square unknown, sample size less than 30, t-test. Okay, t-test is the correct notation for your test statistic if it is sigma square unknown, sample size less than 30. Okay, remember this. Even though these both has the exact same formula, but they possess different notation. So, if the question is sigma square unknown, sample size more than 30, your notation for step 2 should be z-test. But if it is less than 30, so the notation for step 2 should be t-test. Okay class, get it? So these are the three different formulas to calculate step 2 in your hypothesis testing procedures. Now, without wasting any time, let's go to the first example. Come on, let's read this together. Most water treatment facilities monitor the quality of their drinking water on an hourly basis. One variable monitored is pH, which measures the degree of alkalinity or acidity in the water. A water treatment plant has targeted a pH of 8.5. The mean pH level, okay, see the mean pH level and standard deviation of 1 hour's test results based on 31 water samples at this plant are 8.42 and 0.16 respectively. This is a really long sentence, but basically it's telling you that The sample taken is 31 water samples, okay? And from these 31 water samples, the mean pH level and the standard deviation is 8.42 and 0.16 respectively. All right, so this means that the given value here, is this sample information or is this population? Come on class, is this sample mean or is this population mean? That's right, this is sample mean because the whole sentence is talking about the sample. All right, so there you have x bar equals to 8.42, s equals to 0.16, and sample size is 31. Let's continue reading the question. Does this sample provide sufficient evidence that the mean pH level in the water differs from 8.5? Use the 0.05 level of significance to test the hypothesis. Okay, so here, this is your alpha lah, your significance level, okay? So from this question, they give you the sample mean, sample standard deviation, sample size, and also the alpha value, which is your significance level. Sometimes, class, so please take note on this, sometimes the question will not give you any significance level. They will not give you any alpha. So in such cases, okay, this is a new rule of thumb that you need to remember. If the significance level value is not given in the question, so we will assume it to be 0.05. Okay, this is if the question don't give you alpha value, then you use 0.05. Okay, is that clear? So for this question here, the variable that they collect in this little experiment here is pH level in the water. Okay, so the variable here is pH level in the water. The sample is 31 water samples. The population, what about the population, class? So in this case, the population will be infinitely many water samples. Infinitely many water samples. Okay, so I still want you to try to figure out, okay, what is the variable, what is the sample, and the population for each question that you answer. All right, so we just did that for this example. So now let us try to answer the question. Does this sample provide sufficient evidence that the mean pH level in the water differs from 8.5? So yeah, if the question want you to provide sufficient evidence, this is one way to ask you to conduct hypothesis testing. Okay, so the question did not really like directly say conduct a hypothesis testing to test the no, but you need to know that this means you need to conduct a hypothesis testing. Okay, oh, here's a clue to test the hypothesis. Okay lah, so this question is quite direct. It does tell you to conduct hypothesis testing. Okay, now, so first step, what is the first step, class, to conduct hypothesis testing? So the first step is to formulate a hypothesis and state the claim. So the first step here is we need to write our H null H1. So, but before you can do that, you need to identify what is the claim from the question. Okay, which sentence, okay, is the claim that needs to be tested. Okay, which sentence gives you the idea of what that needs to be tested. So I think obviously here this is what that needs to be tested lah, whether or not the mean pH level in the water differs from 8.5. So this is the one. Okay, this is what we need to test. Is it true that the mean pH level in the water differs from 8.5? So come on. Once you have identified the claim, next let us identify the parameter involved in this claim. Okay, so based on the word mean here, then I understand that this is about population mean. Okay, so this is about population mean. Next, we need to identify what is the expression, what is the mathematical expressions that we need to use to represent this claim. So here, the key word here is differs. Differs. Okay, so what is the mathematical expression for differs, class? Differs mean different. not equals to. Okay, so it is not equals to. So based on this information, so I'm going to rewrite this claim. I'm going to rewrite this claim in statistical notation. Instead of mean pH level, I'm just going to use mu. Instead of differ, I'm just going to use not equal sign. So therefore, this claim can be rewritten as mu not equals to 8.5. So this is your claim, class. Your claim in statistical notations. So this is in words, okay, in complete sentence, and this is in statistical notation. Good job. Okay, so this is our first step, but it's not yet complete. Okay, we need to formulate the H0 and H1. Okay, once you have rewrite your claim in statistical notations, next you need to determine whether this claim belongs to H1 or does it belongs to H null. Okay, so you can do so by referring to, oh, okay, before that. So in this case, mu is our parameter and 8.5 is the hypothesized mean. Okay, this is the hypothesized mean. This is the parameter that needs to be tested. Okay, now, so let us determine whether this belongs to H null or H1 by referring to this table. Okay, on slide note page 7. Okay, so can you see where is the not equal sign? Okay, the not equal expression is here. So this is the not equal expression. So based on the table here, this expression belongs to H1. Therefore, your claim belongs to H1. Okay, so you're going to write this at H1. So this is your claim. All right. How do you know it belongs to H1? So again, you need to refer to this table. So this shows that this expression belongs to H1. Okay. So now once you dah dapat dah, you get this one statement. So you can write the other statement, which is H null, which is the complete opposite. Okay, the complete opposite of not equal is equals lah. So if you look at this table here, it's always a pair. Not equal will always pair with equals. Okay, so this will pair with this and this will pair with this. So there are only 3 possible pairs. This is for two-tail test, right tail test, left tail test. So based on this solution class, so we now have a two-tail test hypothesis testing. Okay, so this is a two-tail test hypothesis testing. Right, so yeah, now you're done for first step. The first step is done. Okay, next. The next step, you need to choose the appropriate test statistics and calculate the sample test statistics value. So here you need to choose the correct formula. So come on, let's take a look at the information that we have. So is this the case of sigma square known or unknown? There's no sigma value given, right? So this is the case of sigma square unknown and the sample size is greater than 30. So this is your test statistics formula. The notation for your test statistics is z-test and this is the formula. Okay, so let's just substitute all the value accordingly. X bar is this. Mu naught is the hypothesized mean, okay, which is 8.5. Okay, the value which appear in your step 1 is your hypothesized mean. Okay, so yeah, substitute all the values accordingly and you will get this negative 2.7839. This is your test statistics for this hypothesis testing. Done. Okay, so step 2 is done. Please note that the formula to calculate step 2 here depends on the parameter involved and the conditions of the given scenario in the question. So that's what we did just now, right? We did consider which case is it. Sigma square unknown, sample size greater than 30. Okay, now next step, okay, step 3, which is to establish the test criterion by determining the critical value and rejection region. So how do we do this, class? Now, step 3 has a few things that you need to consider. Okay, first, you need to establish your rejection region. So how do you do that? You need to refer to this table, class. Okay, try to memorize this if you can. If I'm not mistaken, on your slide note, this is on page 12. Page 12, okay? All right, so there are three types of rejection region. Three different types of rejection region based on the types of tests. Okay, based on the types of tests. So come back to our step 1. So here, this is which type of test is this? This is the two-tailed test. Okay, remember, this is a two-tailed test. Mana dia? So equals and not equals is a two-tailed test, right? So therefore, you're going to choose this. You're going to establish your rejection region like this. So you're going to need to draw this diagram, this display, graphical display. Your rejection region will be on the left and right hand side. A little bit on the right hand side and a little bit on the left hand side like this. Okay, all right. So next, after you establish your rejection region, you need to determine the critical value. Okay, determine the critical value. So if you look at this table, the critical value here is alpha divided by 2. Okay, so to find the critical value from the table, you need to use alpha divided by 2. So our question here is alpha 0.05. So divided by 2 is 0.025. That's why in the solution here, we use Z 0.025 as our rejection region. So this critical value is the value that will separate, okay? The critical value here is the value that will separate your rejection region and the acceptance region. Okay, class, so for two-tailed test, you will have acceptance region in the middle and rejection region on the left and right hand side. So the value that will separate acceptance and rejection region is your critical value. So in this case, on the right hand side, it will be Z 0.025, which is 1.96. And on the left hand side, the critical value that separates this rejection and acceptance region is negative Z 0.025, which is negative 1.96. So class, this is how you establish critical value and rejection region. This is step 3. So please take note that the type of rejection region established in step 3 depends on the type of hypothesis testing formulated in step 1. For our case, it is two-tailed test. And then next, please note that the critical value used to separate the acceptance and rejection region comes from the Z distribution table for this question because the test statistic used in step 2 is Z-test. So because it is Z-test, so the critical value that will separate your acceptance and rejection region in step 3 comes from the Z distribution. Alright, so let's say if you use t-test. Okay, let's say if the question is the case of sigma square unknown, sample size less than 30, so you need to use t-test, right? So if your step 2 use t-test, so in step 3, you will need to find the critical value from the t distribution table. So this will be t critical value instead of z critical value. Okay, understand? Right. So please take note on these two important uh, things that will determine your step 3. Okay, these two important notes. Okay, so that is step 3 class. You have established your critical value and the rejection region. And now we can move on to step 4, which is to make a decision to reject or fail to reject H null. Okay, whether we want to reject or not reject H null. Only H null. Okay, step 4 is only about H null. Remember that, class. Step 4 is only about to reject or not reject H null. So in order to do that, you need to recall what is your test statistic value. So in step 2, you calculated Z-test, which is negative 2.7839. So if you look at this number line here, if you look at this diagram, here is negative 1.96. Here is positive 1.96. So where is negative 2.7, class? Alright, so according to the number line, so negative 2 should be on the left side of negative 1. Am I right? So negative 2.7, your test statistic falls in the rejection region. Okay? Since the test statistic is smaller than this negative critical value, so your test statistics falls in the rejection region. So if your test statistic falls in the rejection region, the decision here is to reject H null. That is the rule. So you need to memorize this. If your test statistic falls in the rejection region, you reject H null. If your test statistic falls in the acceptance region, you don't reject H null or you accept H null. Okay, so that's the decision, reject H null. Okay, so you can also write the decision like this. Since Z test is smaller than the negative Z critical value, then we reject H null. That is step number 4. Step number 5, draw a conclusion to reject or to accept the claim. Okay, so step 5 is about the claim. Alright, step 4 is about H null, and step 5 is about the claim, to reject or to support our claim. Alright, so what is our claim here? So you need to recall your first step. Okay, the claim here is saying that the mean pH level differs from 8.5. So based on the decision here, what happened to the claim? Are we going to support or are we going to reject our claim? So based on the decision, so the decision here is to reject H null. So when we reject H null, that means, okay, this H null statement cannot be accepted. Okay, so this is obsolete, sorry. So this statement has to be rejected because of our decision here. Alright, so therefore, when H null is being rejected, so we are only left with H1, which means our claim here, we support lah. Okay, we are going to accept H1. Since claim is at H1, okay, so that means we are going to accept claim. We accept claim because we accept H1. Get it? So we reject H null because of the decision up here. So when we reject H null, we have no choice but to accept H1. Since claim is at H1, therefore, we also accept claim. We also support the claim that the mean pH level differs from 8.5. Okay, so this is the conclusion. At alpha 0.05, there is sufficient evidence to support the claim that the mean pH level in the water differs from 8.5. Okay, so in your conclusion class, make sure that you include your significance level, and then you write that it is sufficient evidence, and then what is the conclusion, to support or to reject. But in this case, we support our claim lah. Okay, alright, so these are the 5 steps of doing hypothesis testing for one population mean using the traditional approach. Okay, class, so I want you to really understand the solutions thoroughly. Make sure you understand step 1 until step 5. You may you may watch this video again and then try to practice on this example on your own without looking at the solution. Okay, after you watch this video, I want you to go back to the original question, okay, and then try to answer this using the 5 procedures, 5 steps on your own. And if you can, then you're good to go. Okay, if you can do it, then that means you do understand how to conduct hypothesis testing using a traditional approach for the case of one population mean. Okay, class, that is all for this video. After you had try on the example, you may want to try on any of these exercises. Okay, try one before our next class. if you can. But if you can't, then it's totally fine. It's totally fine. Okay, that's all, class. Thank you for listening. Assalamualaikum. Bye bye.